I'm Yves. I've built boring lines of business application involving humans. I'm currently working, and that's strange. Nobody was talking in a domain-driven design conference about what domains are there in, or none of the talks. I'm in HR, government HR, so I'm in the selection process, and I build systems, custom systems around that in Belgium, which, if you know Belgium, is complicated, so you can imagine what kind of complication we have that. Online, I'm while off, and the why brings me to why am I doing this talk. This appeared on the DDD, CQRS, ES Slack about a year ago, if I'm not mistaken. I forgot who wrote that. And I didn't follow the discussion afterward because this got my brain into a mode that's not fun. In eventual system, latency is feared by the developer. Eventual consistency is unacceptable for business. Side note, if you're not on the DDD, CQRS, ES, Slack, go there. There are lots of people, and it's active, and we answer questions. The only thing that we are going to do is, if you ask a generic question, we are going to ask, give us examples, so you'll have to talk about your domain, actually. I'll put the slides online, you'll have the link. Don't worry. And there's a nice thing about this one is it's not the paying stuff. So after 10,000 messages, what you wrote is forgotten. So you can write wrong things, nobody will notice afterwards. Okay, latency. Anybody knows what this is? That picture? No? Nobody? The CMB, yes. It's a background microwave radiation of the universe. And that was detected about 50, 60 years ago. And anybody knows or hold the age of that signal?
13 billion years.
Billions of years. It's kind of appeared 400, 500,000 years after the birth of the universe. This is just to make one thing away. Latency has an upper bound. It's this one. So you can go to your boss and say, we will eventually receive a response from this, and the maximum time is billions of years. Yeah? Now, this might sound funny to say that, but any system has an upper bound. Any system has also a lower bound. And if we talk about time, your lower bound is probably going to be the granularity of time you're talking about. This is kind of a side note, but if your business is in days, your granularity is days. So the smallest possible thing that you have is 1 day. If it's in minutes, it's going to be 1 minute, the smallest possible thing. So it has no use to refresh a screen every 5 seconds because of latency and I want the latest data on my screen. If the data is updated once a year. I mean, that kind of thing. Those are things you have to think about. Latency is a fundamental property of the universe, so we can. There's nothing to do about it. It exists in any systems, and the fact is, mature processes replace process by business. If you want to, they deal with it on an everyday basis. The problem is they don't do it explicitly most of the time. And by mature, I mean not old. I mean businesses or processes which exist for a long time and they know where the issues are with latency, so they know how to deal with it. I'll give some sample. Anybody has a definition of latency for me? I ask questions, and so I told you that I like interactions. And anybody want to try it? Oh, I already said it. You can say the maximum is billions of years. No? Nobody? Okay. Wikipedia is your friend here. Latency is the time interval between a stimulation and a response, a time delay between the cause and the effect. That's it. That's something that you can measure. More difficult, eventual consistency, because this talk is supposed to be about eventual consistency. And I did say supposed. Who's a programmer? Okay, who's in distributed systems? Who knows about CAP?
It's the time that passes between the write and the read. So when you do a read, you are not sure if it's the last write or it's not.
Yeah.
So
Well, I'm going to take again the definition of Wikipedia because it's my friend. And eventual consistency is a consistency model used in distributed computing to achieve high availability that informally guarantees that if no new updates are made to a given data item, eventually I'm beginning to have a headache here. But there's one thing that is important: is eventually consistency is one of consistency models. There are other consistency models. This one, if you know about CAP, is about availability and partition tolerance. If you have questions and what the heck is CAP, just raise your hand. That was a test, but nobody does it. Okay, that's my simple, I'm a simple guy. I tend to simplify things maybe too much, but different parts of the system have a different view of the world, which is probably not the world in itself, the state of the world. That's it. Yeah? And it's also something that is existing in all systems. There's no... if society wasn't eventually consistent, we couldn't do anything. We would be blocked by transactions everywhere. So there is no central control in society, almost none. But everywhere, we know that everywhere where there's control, there's like this latency that builds up because you need to queue to have that resource over there. And that's not good. Mature process deal with it. Yeah? Now, I'm going to get one far-fetched real-life example. It's about law. We have a Belgian law. About 20 years ago, and it's about eventual consistency, this one. In Brussels, there is a factory making car, and the management there had the state of affairs of that factory, and they decided to do a collective layoff of 3,000 people. So their view of the company, of that factory, is tomorrow, nobody works there. Yep. Now, I'm the manager, and for me, the state of the world is that factory does not exist anymore. Now, I'm a worker there, I'm going home, and everything is all right, I have a good job, tomorrow I will work. I'm wrong. I have a view of the world that I have a contract, but actually there's a letter coming in tomorrow morning, and I don't have a job. So that's the point of the state of the employee, yeah, which is wrong. And then you have the state, which thinks, oh, this is a good company, employing 3,000 people. They take people every day in, so we need to find a way to increase taxes for them because, you know. And the state is wrong because that company does not work in Belgium anymore. They are delocating. So the point is, they all have like this different views of the world. That was a social drama, and they made a law called, oops, this is not normal. That's not me. Thank you. Which is called La Loi Renault. I'll let you guess which car maker it was. Law Renault. And what they said is, if you want to do a collective layout, you have to follow certain rules. You have to announce it, and you have to give time to make some negotiation with unions, and you have all those steps that must be done to minimize the consequences of that eventual consistent state about people having a work or not. So that's one strategy to deal with eventual consistency is I want to minimize the consequences of something happening because I'm not consistent with the rest of the world, and I know it. Bank accounts, I hate bank accounts, for example. We are going to take leasing. I worked in leasing and in automated decision. Yes, this is also with real-time border. I don't know who... I have a leasing requested, then it goes to some kind of policy rule system, and there are 3 outputs in there, and it's either this request is denied, it's granted, or it's in the undecided. Those are fuzzy terms, those are not the correct terms, but anyway, and that's the goal of that system. Undecided means a human needs to look at it. At that time, that was a long time ago, I was looking at the system in kind of a static ways. I have this leasing request, and what do we need to check those rules to know, oh, is this okay, is this not okay, or does a human have to look at that? Of course, there's the asset, what type of asset are you? Do you want to lease, how much money, and so on? And you look at the last annual account, you look at the bank rating, you could look at commercial analytics done in Bradstreet, and you look at obligo, the total amount of money they owe you. Obligo is also something interesting. But then I kind of put it in another way. It's like one day I had like this thing, annual account corrected. And I laid that off on the stream because I had this problem, is that our system wasn't there. When we asked the annual accounts to the national bank, every company has to put them at least once a year. And I got a problem in the system because there was a second document on that day. And it was like, dear business, what do I do with that? What does that say, by the way? If I put 1 year ago, I have like my annual accounts, and then 6 months or a few months later, there is a correction. What does that say? What is that? It's in the title of this talk. It's eventual consistency. Back then, it was wrong because there is a correction. We made a mistake, and now we are correcting it. We are coping with, or the business is coping with that problem, okay? But I ask, dear business, which one do I take? This one or this one? And the business says, take the one from a year ago. Shoot. I heard someone wanted to say something.
Yeah, I think that's that's affecting you as a person who wants to have leasing.
Yes,
that's not true.
It's affecting the leasing company. Now, if this is a positive correction, more money, it's okay. If it's a negative, that's problematic. Okay, but there's also the other thing is, even without correction, I'm the same type of company, the same numbers, the same asset, and I'm doing it based on this annual account of a year ago, of 6 months ago, or of yesterday. Those annual accounts are about numbers that are even a year before. Those numbers doesn't show the current state of the cash flow of that company. And what does this risk management, I said it, this policy do? It's risk management. It's about risk management. And talking about dealing with eventual consistency of things that have happened in the past is this thing is taking into account on a global scale the fact that this data is outdated. It's in the scoring model. You get that? And I said, yeah, but there's all this correction and maybe things that happens in between and this and that. Yeah, actually, that's why we do this. Because they have more updated data. That's their job to know this updated data. We don't care. It's taken into account into the fact that we as a company don't know the real state of the cash flow of that other company. That's why we use this one. We pay them for that. And the bank also, because every leasing company is owned by a bank, so they ask information to the bank, and the ratings, and that kind of thing. So eventual consistency, that's mature in the sense of they deal with that fact. They know it, and the model deal with this. And on software level, I don't have to deal with this. I just have to get data, put it to a decision tree, and done. So far, so good? Yeah. Who read the abstract? Do you really think that what I wrote about a year ago is exactly what I'm going to talk about now? I'm being honest here, huh? Or maybe not. You don't know, actually. I know, but you don't know. You have a different view of the world. Yeah? So, one thing. The original sentence was in eventsourced system. Let's be honest, it happens in all systems. I just show you that. Latency, eventual consistency, it happens everywhere. Even that database, because I hear sometimes people say, oh, yeah, but I have a database-driven application, so I have this form, I get my data, I fill it in, I save it, I don't have eventual consistency. Yeah, get your screen, lose your connection, have someone having the same screen, changing your data, and you're screwed. Yeah? And how do we deal with that? Who has an event-sourced system in place? In production? Okay, not much. And the other people, they know what event sourcing is about or not? Okay, theoretically or practically? Yeah. Okay. But once you lose the connection to your store, you're eventually consistent. Things could have changed in your store. And you have, of course, optimistic logs. I have a timestamp, I have a CRC or some kind of checksum and stuff like that. This is dealing with eventual consistency in systems like we built them, or still build them today. And you have also pessimistic logs. I want to avoid that something happens. And this works well until you share your database and that you let other systems put, and who never has shared this database with his data store, I shouldn't say database, this data store with someone else? Who has never done that? Hopefully nobody, everybody does that. I mean, it's kind of an entropy things in systems. We share our data directly from the store, which is bad. We should avoid that. So we need to cope with it, and especially in event source system, when you begin to have to reason about it, with time, we are going to become very precise about what happens when, and if this happened before that, and this, and this, and this, and this, and we make that explicit, and that's what people fear, actually. It's the fact that we are making explicit. Before that database connection, the first application I wrote is what like, Yves, you have to use optimistic locking. Oh, okay. Why? I don't care. I'm just banging on the keyboard. Yeah? And we can do two things. We need to most of the time we need to minimize consequences of it, of the fact that we are eventually consistent, or we can minimize the chance of it happening. Most of the time you need to do both. End of the talk. Okay. Now I'm beginning to be a bit more consistent with the description of my talk. CQRS, everybody knows what CQRS is? Someone explain it to me, please.
I wouldn't explain it to you.
Oh, come on. There's no mic.
Even without a mic.
Even without a mic. CQRS, Command Query Responsibility Segregation, and please. That's CQRS. Yeah? I have some data storage, and I have multiple read models, eventually multiple write model, my command handlers, and I have some system querying, and that's it. That's CQRS. If some store would be a database, you can do CQRS with a database, okay? You're not outside of CQRS thing. You don't have to use event sourcing. CQRS plus AS is a nice combination, but it brings complication. But if you just use a database and you have my read model, I have my write model, where do you have eventual consistency in there? Like between actually the query side and the color is bizarre, and the command side. This should be green up there. There is none. If my command side has committed the data to the database and I read it immediately, there is no difference. It's committed because I have consistency. I have ACID properties on my database. If you combine this with event sourcing, we will have some kind of event store. This one, pretty cool. I'm not working for them, I'm using it, and it's pretty cool. I need to add some moving parts to this, because I will have my command handlers, and my command handlers will emit some events that I push into my store in some way. And then I have my query handlers will query some data store, and this data comes from a projection side, which is getting data, and transforming this data into another form. Okay? Eventual consistency is availability and partition tolerance, which means that normally you would want your projections to be completely isolated from one another. So it could be that I have like a list of items to do, which is up to date, and if I look at the detail, which would be another projection, it might not be up to date. I have an obligo, how much money I own is 10,000, and here I see 20,000. Eventual consistency is there. Goes by the latency of fetching the data, or because that process died. Okay. That's CQRS with query handlers. I'm missing something here, and that's going to be the more DDD angle, let's say. I'm missing a reactor over there. Replace reactor by process manager or Saga, I don't care. I got yesterday the question about, I have like aggregate, if I say the word aggregate, nobody is going to fall over, I hope. Yes? Who's going to fall over? What is an aggregate? Oh, you're not helping me, guys. An aggregate is a consistency boundary, point. Yeah? And the rule says you don't share data between aggregates. And there's someone who came, I don't know if he's in the room. Oh, he didn't show up. It's like, okay, but I have this aggregate and this other aggregate, and for that aggregate, if this aggregate is in that state, then I'm making it a bit more complex than what he said, but the words are the same. Then I can't delete that aggregate if those other aggregates are in that state. It was about audio streaming, but it was speaking in terms of aggregate, not about the real domain, which makes it difficult to reason about it. Okay, that reactor is solving the problem of not having to share information between aggregates. I have my projections there. They are listening to all events, or discarding some, listening, and I transform my data, and I make this data available for some system. That reactor does exactly the same, but with two additional features, is I take data, and if this happened, then this happened, then I emit an event, which probably goes back to my event store. That's one side effect that I can have. And I have state, private state. I'm the reactor, I'm the purple thingy. I have state, so my state is private, I don't share it, and I get data, events, and I can eventually trigger an external system. That mail that you need to send, because a user registered on your website. And that external, that could be another system, or that could be an aggregate, which, well, through a command handlers, is going to be persist some events to an event store. I'm not being dogmatic there. Yeah? So far, so good. I hope I bring you everybody on the same state about what I think about CQRS. That was the goal, because there's probably some imbalance. So I hope it's corrected. So where do we have latency and consistency? Most of the time you will have synchronous. Make it yourself easy. Make that synchronous. You can make it asynchronous, but don't. So if I have a command handler, I get a response almost immediately that says, okay, not okay. I do my query and that's synchronous. Give me the list of this, poof, I get the list of that. Where those ones are asynchronous, they are distributed, and I can get eventual consistency over there. And I can get, because a reactor works almost the same way as a projection, it's going to be eventually consistent also there, because they can like die. And then get up, and then you don't notice it, and then I had that once. projection died, and then we have BI calling up and saying, that's strange because we have those numbers and they're not up to date. Which is, okay, we forgot to monitor that specific process, which is not a drama because it's for BI and they need that number once every quarter. They actually look at it once every quarter. So when I'm saying your projection should be available, more or less, it depends on the business. If they look at it and I mean, oh yes, it's down. Okay, restart it. 2 seconds later, it's up to date. Everybody is happy. So it's not a problem if things go down and are eventually consistent because someone will notice it and they will complain. Okay. In the abstract, I said I would talk about my domain, and this is probably the most heavy part. If you have any question, please stop me. If I'm not clear, please stop me because I love my domain, because my job is to get people a job. Which in IT is not something that happens that often. Most of the time it's like something else. How much work do I have? So I need to deep into the domain. So we do, the correct term is comparative selections. So we publish jobs on a government site, and people can enroll, and they have to pass a selection. And those selections, from the point of view of the candidate, is like 3 steps. I will have to pass some generic PC-based test. We have a room with 500 computers. If I succeed in that, I will have a second round of tests which are specific for the job. The first round is purely generic, abstract reasoning, verbal communication, or written communication in that case, stuff like that. And the third step is most of the time an interview. So that's the experience of that pure statics experience from the point of view of the users. That step 1 is the one I'm interested in. It's generic, so we give exemptions. Everybody understand what I mean by exemptions? That means under some condition, you don't have to pass those tests and you can go into step 2 directly. I'm going to go down deep rather deep in my domain, so I hope you don't find that too boring. And one of those rules is if you already work for the government, federal government, you're a civil servant. I might say public servant because that's how we call it in our domain, but the correct word in English is civil servant, so I might switch. If you're a civil servant, and depending on the level of your job and the level of your current position and the level of the proposed job, you get an exemption. Those levels is A, B, C, D, something like that. And those have meanings. You don't have to pass those tests. Yeah, cool. The problem is, I don't know if it's in your countries that's the same, it's extremely difficult to know who works for the government. You don't get a list. There are in Belgium probably 80,000 on federal level. It's a country of 11 million people. But it's extremely difficult to know who is actually working for the government. So we have to ask the candidate, hey, in their resume, they can fill in their resume, oh, give us your current job. I work for the federal government in this organization, and this is the proof. They even have to give us the proof. When I say extremely difficult, we have some sources where we can get that information, and it's the payment systems. Unfortunately, there are different payment systems in place. I mean, for different organizations, and I think the biggest one is giving us like half of the data we need. So we lack some data. So when people enroll, I'm going to switch the slides rapidly. And going back, actually what happens on the selection side, so inside the company, there is a CV check which is going to, resume check, which is going to make some qualitative checks about your CV. To enroll in this selection, you have to be a public servant. Some of the jobs are closed. And then we have the generic test, and then we do a screening of the resumes, which is a manual screening, qualitative. We check lots of things, but one of the things we check is this person, did he give us a proof? Was this proof checked? That's the important thing, because once it's checked, we don't have to check it anymore. Or that was so in the old system, and then you can go on. That's the basic idea, and you can be stopped in your selection at every step. Going back. That's 2 days ago, I think. That's the number, that number here, that's in Dutch, sorry, but the number of nomination that needs to be checked, and they can search something. That talking about a lean screen, I mean, the screen looks like that. It's really focused only on that problem. And that number over there is how much work is there to do? How many of all those selections that are now running, how many people do we need to check? 700. It's not much. Normally we have like 40 selections running in different open for enrollments where this thing, so it's probably spread out about 40. This number can go high. We have selection like with 5 people, and we have selections with like 5,000 people. We have a whole spectrum. So this number goes up and high and up and high and up and high. And the second thing, that what is their work? What work do I need to do? And okay, GDPR, I'm not showing the names, that's the unique number, that's the selection number, that's the type of job. Did they provide a document? And is there someone actually now looking at this case? This is pessimistic locking, this last one. But not enforced by the people. If I look at the screen, I'm not going to check number 1 because someone else is busy with it. Pessimistic locking in an event source system. Oh. That part of the system is event source, not everything. Yeah? So they click, they get some screen, and they can make some decision. This guy is a public servant, or this person, sorry, is a public servant, is not, is something else. Okay, I went back. Okay. Can you see problems already or not? By having this kind of visualization no, I'm sorry, I'm going to ask that differently. Do you have an idea of what that system does as a candidate? I have all those steps, I can fail at each step, that's quite easy. Now I have to add time to it, because we are talking about eventual consistency and we are talking about time. And I have something called the last day of enrollment. I'm saying I'm going deep. Huh? If you find it boring, just say it. And I have actually, from the moment there is a publish, the job is online and you can apply to it. There is the last day of enrollment. Everything needs to be checked. Everything needs to be okay on the last day of enrollment. Of course, I said it could be up to 5,000 people that need to take those tests. So we have like long periods of testing. We have a capacity of 500 PCs and the rooms are full. It's about, if you look, we can test 1,500 people a day taking tests. And so we have this first period of testing. So people are taking tests at this point in time, which begins before the end of the last day of enrollment. And of course, the business is going in parallel to begin to check resumes, because they have to check 1,000 people maybe, 2,000 people maybe, and hopefully less and less and less, because the data gets better. And normally this should not happen. That should be checking the resume from the point of view of the last day of enrollment, and then step 2 begins. So normally here, that resume screening is done. In reality, it's not. So you can imagine when they are making mistakes or they are missing information, what kind of impact that has on the planning. Because people are maybe, I'm saying here, I'm a civil servant, and I'm lying. I get I don't do the test, and I'm not lying, by the way, I'm just making a mistake. And they check my resume here, and they say, no, on the last day of enrollment, you are not a public servant, so my procedure is stopped, because I can't do this testing anymore. But if I'm lying, I'm making a mistake here, and that they check here, I have time to make my test. And if I say I'm not a public servant, and then suddenly I become one, and I have a test to do, so we are on this day, and I have a test to do on this day, and I change my resume, and they check it here, then it has impact on planning everywhere. So there's all kind of timing issues that are interesting in here. Or because we don't know the real state of employment of that person. Okay, put it out another way. I have the CV checked, first line, I have the CV checked, even Stormish. The yellow ones are supposed to be orange, so they are even. CV checked, enrolled, I have my exemption strategies that need to be performed, and what can happen, I can have this public servant exemption granted. Yeah, nice. And then what could happen is that I changed my resume, and who was at Matthias' talk yesterday? Nobody? Oh, you missed something. For those who were, that's a notification up there because my resume is in a SQL relational data, and for different reasons, we decided to make something change. That's not the real term we use, of course, in CV, a notification, because there are new regulations coming up, and we are going to have to review the whole resume information. And so something changed in CVs, my exemption strategies are recomputed, and I could lose my public servant exemption, and other event like, you need to enroll, don't forget to enroll, such kind of notification. Oh, okay. Another case is, the point here is, if you do this kind of exercise, you are going to get at all the detail of what can happen in what order, and is that important. So I have my public servant exemption granted, so the same, I am enrolled, I was granted, and in this case a human decision is needed. Strange name, but it's like, I just made my resume, I uploaded the proof of my employment as a civil servant, but somebody will need to check it out, because people also make mistakes in the data they enter in the form. And what do we have on that event, which is important? Who, the candidate, and what selection it is. And then we go to that screen. I go regularly to that screen. I have work to do. I have to do that one. I take a decision, and the decision I can take is either I confirm it, and I say which organization, which level, and on the day he entered service, because things need to be correct on the last day of enrollment. Either I'm a non-federal public servant, confirm, which means we have regions in Belgium and they are also civil servants, or just because you work for town, or you're not a public servant. Yeah, this is all information I need to build up that query model. So now I'm looking at things from the query model perspective, and I'm doing everything to make that query model as accurate as possible. And when those events happens, I'm going to, again, through an exemption strategies, and two things can happen. I lose my public servant exemption, or I'm granted it. Or nothing happens, actually. And the last one is, I said I am a public servant. It has been confirmed. It has not been confirmed yet. That's kind of the same scenario. I'm a public servant. I have my exemption. A human decision is needed. And then I change my resume. Something has changed, and the exemption strategies are rerun, and I have this public servant exemption lost, which is the case where the business doesn't have to do anything. that first drawing we were like doing with just timeline and putting stickies. We missed that one on the first run. This exercise, we did that with a colleague of mine. It took about 2-3 hours to just, and there are lots of other cases actually. I'm not showing everything, so I'm not going that deep. But it took about 2-3 hours. Until when do I have?
20 minutes.
20 minutes, okay. Still following? The next example will be more easy, but I want to go, I'm probably one of the only people who can talk about his domain in a public way, because it's public. It's based on laws and regulation. Okay, so what can we do now? I want my who. So this list, who do I need to check, and that number to be accurate and as fast as possible. That's again the thing. Now I'm going to remove everything that I don't need to compute my state, my view model. I end up with this. And how did I remove everything? Actually, we had those. This should supposed to be green. Green is query model. What do I have to work on is, that's the first thing we did. I need this, I'm dependent on this, and how much work, I need this human decision needed, and I need the non-federal public servant confirmed, and I need, and then you remove all the other stickies. This is what I need from all, there's lots of events, this is the only thing I need to compute my state, my view, my query side, view state. Do you like that? I don't. There's too much lines. There's too much line, and there's something crossing boundaries here. I have this application which is dedicated to, do I need to make a decision? And I need to make a decision. And a decision has been done. And I'm going to add one thing. This will become clearer in the next sample why I'm doing this. I'm adding one event, and things become simpler. So when I take a decision, of course, I have this event, those events here, but I'm only dependent now on two events, like there is a human decision and a decision was taken. I kind of simplify things, which is more is less in this case. Yeah? And what do I need on those events? Who and the selection, and who and the selection. And you can pretty be assured that I can do +1, -1, +1, -1, +1, -1, +++, minus, minus, minus. That's my number projection. The other one is just taking who, which selection, and some more information that I need to show on that screen. And they basically both need that. Now, we are talking about boundaries. Not aggregate boundaries in this case, but I'm going to draw them anyway, because this is correlated to this, and those are also something that they belong to each other. What I didn't say is that we even source one part of the resume, which is this information about he is public servant, he is not public servant, he did something on his public servant information. That's this one. So we have some kind of boundaries now, and I like that. And if I turn that into streams, it's like this. Stream is a transactional consistency in most store implementation. So I have one stream, which is called decision, and the only thing that it has is human decision needed, human decision needed, human decision taken, and I just need to read that stream to get my number. Yeah. Compute that stream. And then I have public servant John, which things happen which are not relevant for this talk, and oh, there is a decision taken, federal public servant confirmed, yeah. And then later, oh, it's not confirmed anymore, and later, and all the history of that kind, this information, and I have like 80,000 of those streams, and one decision stream. It's a singleton. Okay, How do I compute my number? I do plus minus, and I read from the beginning of time until the end of time of that system. I told you I have 80,000. On day one, I had 80,000 because we did an import of data. How many events do you think I have on the decision? Lots. If my projection should crash for any reason and I need to reconstruct it, and now we are talking about latency, what can I do to reduce the amount of time to reconstruct that stuff? I don't have a slide for it, but I could make snapshots. If you hear events, oh, I need snapshots to make it fast. And I could snapshot on the stream, or I could snapshot on the second stream. We use snapshots on the stream, which means I need to read backwards and I need to read forwards, and it works. I have something against that way of dealing with, okay, I need to be as fast as possible if I reconstruct my query, my read models. It makes things complicated. Those streams, I read them, all those 80,000 streams, I read them from left to right. And this one I'm reading from right to left. And then I have something in that code that is different from the rest. From my point of view, we introduce accidental complexity there. There's something that's not working the same as the rest. And if I take a second stream, I have other problems that can arise. But it works, so it might be okay. We are going to find a solution for this. Okay, I leave the government and I work for this startup, and they have this brand new website. That's not true, I'm just making that up. And they have this constraint of, now we are going to go to the right side, my command side. Username must be unique. That particular example popped up in a meetup 3 weeks ago or 4 weeks ago, something like that, but I liked it. So, username must be unique. And the story goes like this. As a user, I want to register I want to choose a username so that I can register on the website. And that's a happy pass. The not happy pass is, oh, the username is already chosen, so I get to choose another name so that I can register on the website. What is wrong with that story? Please help me. Someone, say something. It's not the story itself. I hate the word user because that's my wireframe. I'm not a user if I'm not registered. That's the DDD. That's not the DDD stuff. That's not what DDD is about. That's not about the name user in this case. But that is what I can do on my website. I can choose a username and I can register. And I must make sure that the username is unique. And remember, my command side is synchronous. But to know if my username is unique, I need to read something. I need to read something. So, by the way, I said as a user, I can't do anything on that website because I'm a user. That's not true. I can do something that is accept the cookie policy. And that cookie policy is annoying because I need to click on stuff before. Okay. I'm not a user and I need to accept your policy about tracking stuff. That's strange to me. But okay, what's the simplest way to implement this feature? Username, I can register. Simple. How would you do that normally? Don't think about event sourcing.
With a cache mechanism.
I'm a new website. Why do I need a cache? I don't have any users, and I don't expect to have 10 billion users tomorrow. If I have 1 million, I'm happy. A database is enough. Is it enough to ensure uniqueness of username if I have a table user? That's standard stuff, I mean, yeah? And username, I have a primary key and some other information. Is this enough to implement that feature? Why not? You have to?
You have to synchronize with the write.
You have to synchronize with the write. I have transactions for that. This is a database. I have transactions. If I'm writing something, nobody can read. I don't have phantom reads. This is enough. Yeah? As long as I don't have billions of users. Agreed. And then I'm going to do something complicated like a cache, and a cache is eventually consistent. And the other problem is that you know that this is going to happen. That table is going to be locked to everything, and this is not good. So let's model what happens in reality in time. Because the fact that it's unique, there is this latency of information, and there is eventual consistency on the other side. So that's my system on day 0. There is nobody on my system. And then John registers. It goes to something that's check uniqueness, and John registered. Yeah? Then Do registers. So the first one happened. Do registers, check uniqueness, Do registered. Yeah? Sounds okay. Yeah? And then we register Do. John registers, and John already registered. Yeah? And I'm going to do the same exercise. What do I need in the first purple sticky, or the second purple sticky? What do I need to know of the past? I need to know that John was registered. To check the second sticky, I need to know that Do was registered, and I need to know that John was registered. That's the temporal dependencies that I have. Yeah? Make sense? What did I do? I modeled this. Insert primary key variation. Did I gain insight by doing this? Did I win something? I modeled insert primary key variation. Yes, I can model a database. So I didn't get any insight by doing timelines. And there's one thing, it's difficult to spot that kind of thing. That is simple, but you have to be critical. Do I gain insight by adding stuff? So I'm going to do exactly the same trick, and that's one trick that you can do, is split things up. What if instead of saying I'm registering a user, I'm actually a username, I'm actually claiming that username. And I'm claiming that username for a certain amount of time. I claim username John. At the same time, 2 commands. I do register John. I go to my policy, username John claimed, everything is all right. And I have, at the same time, John is registered as a user with all the user information. And then Do registers, and Do does not confirm his email. Let's pretend you have a confirmation email and you confirmed it. There is a flow behind it. And then, actually, I chose to model that as I have some information about John Doe. I have his email, I have this information. Yeah? And then John claims a user. But John was already registered. But I still make another John user, which make username not an identity anymore, by the way, if I'm doing this. And then I made a mistake in my slides. That's the wrong one, sorry, but you get the point. Is that last stickies, if I want to claim username Do, can I do that? He never reclaimed it. What's missing here is that certain amount of time has passed, 15 minutes, and then this claim there is gone. You don't have it anymore. So someone else can register as Do. And what do I need to make this policy work is actually only this. Yeah? Boundaries, and those are now aggregate boundaries. Transactional boundaries, if I persist this information, it's going to be all right. So I have one aggregate, which is unnamed. Naming is hard. That's why I didn't put any names on these purple stickies. And I have, one aggregate, this one, and the same trick here. I have lots of user information aggregate. By the way, don't ever do that in production. Use something that exists. Don't do your don't even show your user registration, except if you need to actually have really important information about registration. This is a sample. And so I define boundaries, aggregates. An aggregate is a stream, and if I look at what's happening, I have username claimed, and other events that can happen, and this aggregate num is called username must be unique. That's the name of that feature. That's actually a class or a function or something in your system that has a specific name and that says, we have a constraint called username unique. We don't have a primary key constraint on the database table. Again, that's probably not what you want to do with user registration, but those are the kind of tricks that you can use to separate things and make this as fast as possible. Why am I doing this splitting of things up? I can make this one really, really fast if I need to. I can take decision about the latency. What is the acceptable latency of this? I can concentrate only on this and not on the rest, because you know what? Eventsourced system. That could be just a database table. That's enough. This one is sourced. This one, I don't need to source it. If I don't care about this information, anybody can build this. You get this information inside, just make sure the insert is correct. And just make sure to translate this primary key violation in like username is not unique and you need to chase another one. That's it. If you do this kind of exercise and split things up, you can begin to decide, I have other requirements about latency and eventual consistency, and I can choose to use a database. This is, by the way, what most people mean when you don't need to even source a whole system. That is, even inside the system, you can have on the write side and the read side different strategies for good reason, that this is probably better than just having a stream of event. Because my select statement here is always going to be faster. I hope so that you can make a select statement about 1 million record fast, because if you can't, don't even think about doing event sourcing. And you have that. Yeah, make sense? So, that's the end of the talk. Latency is a fact. Eventually, it's a fact, and in my experience, you need to just draw a timeline and do the exercise of timeline and splitting things up. That's it. And that's not an advice, that's just my experience. So if you find something better, or that works better for you, just do it. If you want to do event sourcing, there are 2 books that you need to read. One old, and it's about messaging pattern, because event sourcing is mostly about messaging pattern, and it's a really excellent book, hope. And there's the other one of versioning event sourced system. Just buy this one because it gives all the money to charity. It's free on Limpub, but buy it. Voilà, that's it. Questions? Thank you.